Okay, today's lesson is about how to calculate the percent composition of compounds. And so first we have to remember a percent. A percent means that I have a part divided by the total times 100%. And in this case, I'm going to use mass. So what I really want to know is the percent by mass of each element in a compound. And the way that I'm going to do that is to use molar mass. If I just assume that I have 1 mole of the compound, then I can use molar mass as my total. And then it's a pretty simple calculation after that. The percent mass of each element stays constant even if I don't have 1 mole. And this is a really important piece to remember, and we'll do an example problem with this in a little bit. This is useful today with unknown compounds. If I don't know what a substance is, I can run a couple tests on it and figure out the percent of every element in there, do a couple other steps to figure out what the mass is of each element, and then figure out what my compound is there. So let's do an example here calculating percent composition. So let's say I want to calculate the percent composition of water. I should know the formula for water is H2O, and the molar mass for water is 18.02 grams per mole. It's a fairly simple calculation at this point. So what I want to know is the percent of that compound that is hydrogen and the percent of that compound that is oxygen. So I'm going to do it for hydrogen first. I know there's 2 atoms of hydrogen, but they have their own mass, and that's the 2.02 grams, because remember that 1 hydrogen was 1 gram, but there's 2 of them. And then I just divide that by the 18.02 grams, which was my total molar mass. When I multiply by 100, that's 11.21%. So what that means is that by mass in my compound, hydrogen represents 11.21% of that. Oxygen, in comparison, is a much heavier atom, and so this has a mass of 16.00 grams, and I divide that by my total mass, multiply by 100, I get 88.79%. These both should add up to 100%, right? Because that's 100% of your compound. So, but just double check that in case, it's close, or you get something like 150%, then you made an error in your calculation. So I take my part of my element, my mass of my individual element, and divide it by the molar mass. Even if I didn't have 18 grams of water, the percents would be the same. So in every sample of water, it's 11.21% of hydrogen and 88.79% of oxygen. Okay, so let's try another example here. So what is the percent carbon in C5H8NO4, the glutamic acid used to make MSG, which is a compound used to flavor foods and tenderize meats? So I need to first calculate my molar mass, and so I know how to do this from before. I'm going to list out all of my elements. Carbon, there's 5 of them, and each one has a mass of 12 grams. So altogether that's 60.05 grams. Hydrogen, there's 8 hydrogen times 1.01 grams, and that's equal to 8.08. Nitrogen, there's only 1, so I multiply that by 14.01. We'll put grams on the ends of those. And then oxygen, there's 4 oxygen, so that's 64 grams. When I add them all up, I get 146.14 grams per mole. And now it says I want to find the percent that is carbon. And so I'm going to take this mass of carbon and divide it by my total over here. So 60.05 grams of carbon divided by 146.14 grams of my compound, let's say. When I multiply by 100, I get, I didn't do that math yet. 60 divided by 146.14 equals 41% carbon. Okay? So 41% of my mass is represented by all those carbon atoms, by those 5 carbon atoms. Okay? Let's do another quick example. Whoop. Okay, here we go. So next I want to find the percent of oxygen in potassium chlorate, KClO3. So I'm going to do this the same way. I'll give you a minute to calculate the molar mass of potassium chlorate, and hopefully you should get a mass of 122.6 grams, okay, of KClO3. I want to find the percent that is oxygen, and so I've got my 3 oxygen atoms. All together, those have a mass of 48 grams of oxygen. I divide that by my total mass. When I divide that and I multiply by 100, I get 39%. Okay, so fairly simple calculation at this point, but now let's take a look at the second problem. How many grams of oxygen can be obtained from 5 grams of KClO3? So this is what I was referring to at the very beginning, where the percent of my compound stays the same. So no matter what my sample is of potassium chlorate, 39% of it represents oxygen. So instead of the 122.6 grams, I only have 5 grams of KClO3, which is a much smaller amount, but I know that 39% of it is oxygen. So I'm going to take my 5 grams of KClO3, multiply that by 0.39, and I get 1.95 grams of oxygen. And that kind of makes sense because it's less than 5, all right, and it stays constant. That proportion stays the same. 39% of my compound is oxygen. Okay, so stop here, do the worksheet that I gave you that practices percent composition, and we'll see you back in class on Monday with a short quiz about what you saw here today. All right, see you guys on Monday. Bye-bye.